Greetings, geometry students. This is Dr. Heron talking to you about the second part of math logic. That should say math logic 2, biconditionals and definitions. And biconditionals and definitions work together. They're essentially the same thing. A biconditional is a definition in a couple different senses. We'll talk about what that means. So, quick review. Conditional, converse, inverse, contrapositive. So when you are looking at a statement, putting it into an if-then form. So if I have this statement, a number can be divided by, that can be divided by 2 is even. So you could say if a number can be divided by 2, then it is even. Okay, so then converse would be if a number is even, then it can be divided by 2. So the inverse means I'm switching meanings. I'm changing, I'm using not. So if a number cannot be divided by 2, then it is not even. And then the contrapositive, that's a contra with a plus sign for positive. Then a contrapositive is you switch that, okay? So it goes, if a number is not even, then it cannot be divided by 2. So now I look at, are the conditional and the converse true statements? So if a number can be divided by 2, then it is even. That is a true statement. If a number is even, then it can be divided by 2. That is also a true statement. So if it is true forwards and backwards like that, then I can write it as a definition, which means I'm going to write it as a biconditional. Okay? So biconditional means I have to use the phrase if and only if, and the shorthand version is that. Okay? So if I was going to write this as a definition, I would literally say a number can be divided by 2 if and only if it is even. Okay, so that's kind of the way I would write that definition. So for geometry, for logic, that's going to be kind of the proof of a definition. If it works forwards and backwards, that's how I would solve that. So now, a counterexample. A counterexample is used to show that a conclusion is false when the hypothesis is still true. So this means first part true, second part false. All right, so if the sun is out, then it is warm. So a counterexample would be, the sun is out in January, and in Minnesota, and when it's January, it is not very warm. So a lot of times the sun is out and it is well below freezing, so it is not warm. So if I'm looking for some counterexamples, counterexample means the first part is still true, but this part is false. Okay, so two angles are supplementary. Supplementary means adds up to 180 degrees. They form a linear pair. Now, a linear pair looks like this. Two angles that share a side, that together make a line. So yeah, technically a linear pair is supplementary, but there are other ways to have a supplementary angle that are not a linear pair. So this would be considered a counterexample. So if two angles are congruent, then they are complementary. Complementary means they add up to 90. Congruent means that they are equal to each other. They have the same measure. So I can show, you know what, I can just show this. I can say, you know what, I've got a 30-degree angle here. I've got a 30-degree angle here. Those two together are congruent, but they are certainly not complementary. 30 plus 30 does not equal 90. So let's consider this statement. There are 5,280 feet in a mile. So if the distance is 5,280 feet, then it's a mile. If the distance is a mile, then it is 5,280 feet. So the inverse is just going to be if the distance is not 5,280 feet, then it is not a mile. And the contrapositive, if the distance is not a mile, then it is not 5,280 feet. So, excuse me, then it is not, so then this is true and this is true, so I'm going to go biconditional. So the way I'm going to say this is a distance of 5,280 feet. Hold on, I screwed that up. I'm sorry. Let's back up. Okay, so here's why I want to say this. A distance is 5,280 feet if and only if it's a mile. That's how I would say that, okay? So that is the end of the notes. After this, there is a quick review and then a small quiz. So make sure that you go into my quizzes or Wayground and do that quiz in there, and then go on to your quiz.